Hello everyone, I'm Anik Mukhopadhyay. I'm back with the actual video of the topic which I promised, Carbene Lecture 1 of Chemistry. So as I promised, I would upload it as soon as possible, and here we have it. So let's not waste too much time. All of you gather your books and copies and sit down, open your copies. Unless you are the real Slim Shady, then you are requested to stand up. Nobody got that joke. I should really stop making jokes nobody would understand. Okay, so this was the title. Title is supposed to be at the top, right? Yeah, some things are meant to be at the top. Like, oh wait, this video is age restricted. I can't say anything I want. Okay, so what is carbene? What is carbene? The definition, formal definition, we should know. Although that barely helps us, still, for let's say Shobhotar Khatir, definition. So they are nothing but they are electron deficient. Electron deficient, you know what electron deficient is, right? Which octet is incomplete. Electron deficient neutral carbon containing groups. Carbon containing groups. Okay, now let me explain each term very well. Electron deficient, I have already explained the meaning, right? Okay, neutral. Neutral means net charge equal to 0. I know that you understand what neutral is. And carbon containing groups, so something like C, then A, B, C, D, something like this. Although this won't be required, so I would just erase this thing. Okay, so that's the thing. And please remember, this neutral word is very important here, because all these things are also, what's the word, all these things are also satisfied by carbocation, and carbocation has all these things. They are electron deficient, they are carbon containing group, but they are positively charged, whereas carbene is neutral. So let us just start. You know the definition, but definition hardly explains anything these days, so let me draw what a carbene is. So first of all, the whole thing that what a carbene is controversial. Why? Because there are two types of carbenes, of course, as if the word carbene wasn't enough. So carbene, there are two types. One, it's the singlet carbene, and the second, it's the triplet carbene. What's the meaning of this? You won't understand right now, don't worry, but also don't worry, I will explain. Okay, so this is the singlet carbene and triplet carbene. These are the two types of carbene, and I will of course draw the figure of these two things. Let me draw the figure of singlet carbene. Suppose this is a carbon. Here I have something X, something Y. I know usually X and Y means halogen, but this time this is not the case. Here we have one orbital in which we have paired electrons, and in another orbital we have completely empty. Please note, these are paired electrons, right? You know what paired electrons are, right? That if one is up spin, another would be down spin. And what's a triplet carbene? Triplet carbene, first of all, this part is common. This also has two orbitals, but instead of one vacant and one completely full, this has two semi-filled orbitals. So this is the difference in there. Okay, now let me just save this slide and start a new slide. Let me pause the video for 1 second, please. Okay guys, so at first what we are going to discuss, of course we are going to discuss the singlet carbene. Now first of all, pink heading, very beautiful, of course, that's the rule. Heading should be pink. I'm kidding, don't worry. So let me draw the structure which I showed before. Wait, this thing looks very ugly, kinda like me. Okay, so as I said, there were one paired electrons and one set of paired electrons and a vacant orbital. Now what will we do? We will study the properties of this, that what is this, basically what does this mean. So see, first of all, you can see this has two sigma bonds, like that isn't really hard, like this one and this one. Okay, it has one lone pair, plus 1 vacant orbital. Now you know what does a vacant orbital mean. This means it is an Lewis acid. What are Lewis acids? Which accept lone pair electrons, and in order to accept lone pair electrons you need vacant orbitals. They are also called electrophile. Okay, so this is one point. There are many other points. Let's see. Okay, these are paramagnetic. Now tell me, sorry, extremely sorry, these are not paramagnetic. I just went with the flow and wrote the wrong thing. These are diamagnetic. Now what is diamagnetic, what is paramagnetic? Diamagnetic means which is repelled in magnetic field, right? Repelled in magnetic field. And what is the criteria for something to be diamagnetic? The number of the number of paired electrons must be 0. And you can see, what did I say? I think I said that number of paired electrons should be 0, while number of unpaired electrons should be 0. Number of unpaired electrons equal to 0. As you can see, these are paired, so there are no unpaired electrons, so this is diamagnetic. If there was even one unpaired electrons, it would be called paramagnetic, which would be attracted in the magnetic field. Okay, other than this, let us calculate, more like find out its hybridization and geometry. Okay, how do we find out the hybridization? First of all, we calculate the steric number. What is steric number? Number of lone pairs, this has 1 lone pair, and number of sigma bonds, this has 2 sigma bonds. So 1 plus 2 equal to 3, and 3 means sp2. Let me write some more. 2 means sp, 4 means sp3 or dsp2, depending on the case. You don't need to worry about this right now. Okay, let me just cut this, because in chemical bonding and this you would only need sp3 for now. Okay, and this is the sp2 case, right? So what should be its geometry? It should be trigonal planar, as you know. Trigonal planar with bond angle equal to 120 degree. Now see, what actually happens is, this is the carbon, this is x, this is y, and here we have the lone pair instead of z, like there was supposed to be a z. Now what can we see? We can see the atoms, we can't see electrons. Electrons aren't visible like that. So the shape observed would be this, right? And why is this bent? Because of course lone pairs always cause repulsion. So the structure observed would be bent. Please write it down, this is extremely important. Okay, now what else can we say about this? Well, it is bent, it's deficient in electrons. Well, all of them are deficient in electrons because they don't have they have incomplete octet. So let me write here, all carbenes have incomplete octet. Doesn't matter what type of carbene it is. Okay, I hope you understand that. So this was our singlet carbene. Just let me check 1 second that is there anything else that needs to be added. Okay guys, so I checked, there is nothing left in that video except not in that video, in that slide, except this one small thing called the spin multiplicity. Now see, I am giving a disclaimer of this. Okay, this is a purely quantum mechanical term. So yeah, take it with a grain of salt. Like, this is way out of the scope, but what can we do? Sometimes these things are asked. I'm not telling that it's right to memorize things without knowing them, but the honest answer is, in order to know what spin multiplicity is, we have to spend so much time over it that honestly it won't be worth it. So if you don't want to learn anything without completely understanding, you can skip this part. This probably won't affect you. Okay, so 99% not important, I'm telling you that. So you see the spin multiplicity of singlet carbene, I taught the singlet carbene just now, right? Of singlet equal to 1. That's why it is called singlet carbene, and of triplet equal to 3. That's why it's called triplet carbene. So yeah, that was the only thing that's needed about spin multiplicity. It might come in integer type question, that's all. Like, okay, so now let us get to the real thing, which is the triplet carbenes. Let me write it. This was number 2, triplet carbenes. So first of all, of course, the rule is pink wronged heading, and with that we have the structure, our beautiful structure, up up. Now one interesting thing directly which you can see, these are unpaired, these are not a lone pair. So what the intelligent people can directly say something, it is paramagnetic. Why? Because unpaired electrons are there, it has no lone pairs, that is obviously you can see. Okay, and these are not Lewis acids, not Lewis acids. Why? Because for someone to be a Lewis acid, they need to have that box. What's the box called? Vacant orbital. Then what are these? These are called biradicals. Now what does biradical mean? Don't worry, I'll tell you. Radical mean anything with unpaired electrons, unpaired electrons. And what does bi mean? It means 2. Okay, yeah, this is a purely educational video. So it means 2. As you can see, there are 2 in unpaired electrons, so this is a biradical. Isn't that complicated, right? Now let us see its hybridization. What do we have to do? We have to calculate the steric number. We can see there are 2 sigma bonds, this one and this one, and how many lone pairs? 0. So this gives us 2. And what is 2? sp. And what should sp should have been? What is the regular geometry of sp? Should be linear. But as we know, there are repulsion and attraction, well, basically repulsion from the electron, so something would go wrong definitely. It's like Murphy's law, we can definitely say something will go wrong when there are so many electrons here. So you see, as you know, both of them will give repulsion, right? This will push the bonds here, but similarly this will also push the bonds here, and as both electrons are identical, they will cancel each other out, so net shape is linear. This is a very important term, not term, point. So these were the most important points. Other than this, what do we have? Of course, the sp hybridization thing you need to understand and remember. Okay, they follow Hund's rule. As you know what Hund's rule is, first unpaired electrons up up, then down down, not up down up down. Whereas the singlet carbene didn't follow because it was up down 0. Okay, you remember in atomic structure, right? Up up down down, like that. Okay, so that was basically it. That was basically today's video. There is not much here to tell you, but I would give you a small sneak peek about the coming video, which would be its continuation, of course. In the next video we would continue with formation of carbenes. Formation of carbenes, like by now you know what carbenes are, but you have no idea what they are used for, like what are they good for, right? So let me tell you one thing, let me spoil it a bit. They are why did I write A? Wait, extremely sorry for that. They are reaction intermediates. Yes, just like transition states of SN2. Wait, in SN2 transition states are used. There is no intermediate in the SN2 reaction. Just like carbocations of SN1 and the carboanions of E1CB and things like that. So if you want to understand the reaction, not just memorize it, and you have to understand the mechanism, and in order to understand the mechanism you need to know this. And you would be surprised to know which reactions use this carbene mechanism. Some of our old friends like Reimer Steinman, yes, and Arndt Easter reaction. I won't write the spelling, okay? I know I would murder the spelling, then Arndt Easter himself would rise from the grave and copyright strike my video. So that was it, guys. I would explain the mechanisms in the later videos. All of this would be done. Formation of carbenes would be studied. Reactions involving carbene and their mechanisms would all be studied. And then if there is time, I would do a practice session also. So that was the video. Stay tuned for the next video. I would upload it as soon as possible. So goodbye everyone.